Hi guys, Lois here, and in this video we're going to talk about another topic, which is direct or partial variation and linear or non-linear. Okay, let's begin with our lesson today. What is direct or partial variation? First of all, I would just want to talk about this direct variation first. As we got the formula is y equal to mx, and it's with no constant term. The constant term, we know that is the plus b that we learned in linear equation, but for direct variation there is no constant term, right? And go through the origin. Go through the origin. The origin here, which is 0 and 0. Okay. So what is about the partial variation? Is have the formula is y equal to mx plus b, which is b is different from 0. We need to different from 0 in order to different from the direct variation. And here constant term is the y-intercept, which is the b, y-intercept, and does not go through the origin, which is 0 and 0. Okay, so I can put an example right here for us. Is here's the plane, and the direct variation will be like this. Let's go through the origin, which is 0 and 0, right? But for partial variation, I give a plane right here. This can be like this, and this does not go through the origin, which is this point, 0 and 0. Okay, so I have a conclusion here as well. Both are linear, but direct go through origin, and partial do not go through the origin, right? Partial and direct. Okay. Okay, let's move on to our example. The example is here is quick check. Is it a direct variation or a partial variation? For first equation, what is that? Is it direct or partial? Okay, this one is direct variation because this goes through the origin and it does not contain the constant term. This one is direct, right? And this one it's got a constant term, which is plus 4, and when we put x equal to 0, y is equal to 4. So it means this one does not go through the origin, which we can know that this is partial variation. Okay, let's go to second part, which is rate of change, linear or non-linear. Sorry. first of all, I just want to mention about rate of change. What is that? And rate of change here have the formula is delta y divided by for delta x, and plus equal to y2 minus y1 and all divide x2 minus x1. And this one show the change over time of a function, right? So let's move on to next part. So right now we got two is linear and non-linear. Linear, as we know, is a straight line like this, right? This is straight line like this one is linear, and for some this is non-linear. Okay, but what are the properties of that? Let me begin with linear relation first. This one has constant rate of change. Which is delta y divided delta x. Like I mentioned before, right? This needs to be constant. Constant means it's not changed by time. And its graph is a straight line. Right? Okay. And what is about non-linear? Non-linears is need to have doesn't have the constant rate of change. It's not constant rate of change. And the same thing, its graph is not a straight line. As long as it's not a straight line, it will be non-linear. Okay, and I can give an example right here, this one. Okay, so linear can be this one, or even this one, or even like this one is also linear. As long as it's a straight line, it's linear. And for example, this one, y, x. This parabola is not a linear, it's a non-linear. Or we can get this one is also non-linear. Okay, let's move on to our example of knowing that these are linear or non-linear. So first of all, we got this equation, which is 4x minus 1. This one we already learned before. It's had the formula of linear equation, which is y equal to mx plus b, right? It's the slope intercept form of linear equation. So we can easily know that this is linear relation. Okay, so to the second question is a little bit new for us, but we can, when you see the table like this, you can try to calculate the rate of change, which is delta y divided delta x, right? And first of all, like for example, I choose this point and this point to calculate the rate of change. So the delta y need to be 4 minus 1, and delta x is 2 minus 1, which is 3 over 1. Is equal to 3, right? Remember, it's 3. Okay, so if I choose another, what if I choose another point to calculate, to prove that, to know that is it have the constant rate of change? For example, I can choose this part, this point to this point, which is 7 minus 1 divided 3 minus 1, which is 6 divided by 2 is also equal to 3. Alright, is it the same rate of change as for the first one? So we know that the rate of change from this point to this point and from this point to this point is the same, and we can, at this point, we can conclude that this is a linear already. But I want to do another thing, is that I calculate more in order to be more exactly things. So I choose this point to this point, which is another point. We need to calculate this to know that is it 3 or another number. 9 divided by 3, which is also 3. So we all got that from all point. This is a constant rate of change, so we can know that this is a linear relation. Right, so last thing, is this a linear or non-linear? For this one, we need to calculate the rate of change. Like for example, I take x is equal to 0, so therefore I get the y is equal to 2 multiplied with 0, which is also 0, right? And x is equal to 1. The y right here is 2 multiplied with 1 power of 2 is 2. But when I choose x equal to 3, so I got y is 2 multiplied with 3 power of 2 is 18, which 18, the rate of change from 2 point here is 2. We already got, like, because 2 minus 0 is 2, and divided 1 minus 0 is 2. So we got the answer here is 2. But whenever we calculate the rate of change of the last point, we got 18 minus, I compared to this point, right? I got 2 and divided by 3 minus 1, and the rate of change here is much different, is 8. So we can conclude that this is not a linear. Okay, let's move to last part of our quick check. This we just quick check. So this one will be homework today, and you need to prove that this one is a non-linear. It's non-linear. This one is also non-linear. This one is a linear. And this one is also linear. And we need how can we know that? We need to calculate the rate of change. And whether it's constant is the linear, and if it's not constant it's not a linear, it's non-linear relation. So with that, I'm done for today. Thank you for listening. Okay, this is the end of the lesson already. So if you need extra help, you can check in the description and reach out to me through Gmail or Facebook. I'm happy to help. Thank you.